Pazalaga here. I'm going to show you a replica of the true 3.6 inch circumference circle. It's where all the squares from the circle and triangle originate from. The equilateral triangle height reciprocates the diameter to equal 1. It's also the equilateral triangle length's square. So as we look at this triangle, we're going to find the circle that it belongs to balance number by multiplying the diameter by the equilateral triangle height. So as you look at this circle, the first thing I want you to notice is the triangle that you're looking at. It's the most important triangle inside of the circle. It's the 30, 60, 90 right triangle. Not only does it contain the diameter of the circle, but it also contains the radius of the circle, which is the opposite side, and the adjacent side is the measurement that will get you to 100 degrees on your circumference. And it's also the equilateral triangle length. This is the reason we have 360 degrees in a circle, is because we're finding this original circle in every other circle. This triangle is known as the 30-degree triangle today because at 0.3 inches, this is the height and width of the triangle. This is our example triangle, and the 2 degrees is 53.130 degrees and 36.869 degrees. So whenever we find our lengths for our example triangle in the original circle, here's the lengths for the triangle inside the true 3.6 inch circumference circle, and I have circled their squares. Now we're going to find our balance number. The hypotenuse is the diameter of the circle, and if you take 75% of that, you'll have the equilateral triangle height, which is 15. 20 times 15 is 300. This is our balance number with our squares to the circle that belongs to this triangle. So get out your calculator, because we're working with squares. We're going to use the square root button. Now the original 3.6 inch circumference circle has a diameter square of 4/3. So to find the hypotenuse diameter, we're going to take the square root of 1.3 repeating and multiply it by our balance number, 300. You'll see you get 20, which is our hypotenuse diameter. Now, the square root of 0.48 times 300, you'll see you get 12, which is our adjacent side. The square root of 0.53 repeating times 300, you get 16, which is our opposite side. And for the circumference, the square root of 12.96, because 3.6 squared is 12.96, times 300 equals 62.353829072.